Okay, so this is the second video in the series of building your own 3D printer board. In the last one, I showed you how to connect the 4 steppers or more if you need. And now we'll continue with the rest of the circuits. So we need a thermistor to read the temperature of the bed and the print head. And then we need some transistors to turn on the heater and the fans. And this is the circuitry for a probe for the bed that uses more than 5 or 3 volts, that uses 12 or 24. Okay, so this is how I made a board. I started making it on the spot, so that's why I'm having many boards. Ideally you should put them all on one single board, but I build them as I went, so this is how it is. Okay, so here are the transistors. This one that has an aluminum for cooling is the one that goes to the print head. So this one is gonna provide 50 watts, and these two ones are just for the fans. These ones are using very low current, so I put no. I think even this one would go without this radiator, but I had it and I just wanted to use it. Okay, so let's start with the transistors here first. This is a transistor, how it looks on the schematics datasheet. Okay, so what do you need to connect it to the microcontroller? It's two resistors. Basically, to turn, you put here the high voltage and here the low voltage, and normally this one is closed. In order to turn it on, you need to charge this capacitor between the ground and between the gate and the source. This is the 0 volt, the ground, and this is the gate to open, and this is the plus. Okay, now when the micro provides 3.3 volts or 5 volts, normally this capacitor, when it starts charging, it starts drawing a lot of amperage, and you might burn the micro if you don't put a resistor here. Normally these micros have some internal resistor, but since we are not programming it in Arduino directly, and we're not sure what Marlin or other firmware does, it's better to use a capacitor. Even if you do it with Arduino, it's still better, so you don't forget and burn your micro. Okay, so the size of this one, you choose it based on the maximum amperage that the microcontroller can provide. In case of the ESP32, it's 40 milliamps per pin. So if we divide this, you need at least 82 ohms, so let's say 100 ohms. But I wanna use it interchangeably, so I wanna use the Raspberry Pi Pico that has a maximum of 16 milliamps per pin. So this would require a 206 ohm resistor. But it also has a limit of 51 milliamps per this one, because this is the limit of the onboard chip that provides the 3.3 volts. I'm not sure exactly how much this one can provide, but anyway, it's better to use a bigger resistor here, because it anyway doesn't matter. So I calculated with 1 kilo, it will provide 3.3 milliamps, which is fine, because this capacitor has a capacity of some picofarad, so it will charge very fast even with 3 milliamps. And anyway, in at least what I used it works very fine. There's no delay or something. Maybe if you are using like specific circuitry, it might matter. And then you need this one, because in order to turn off the transistor, because to turn it off you need to discharge this capacitor, and if this one goes from high to low, you might it will not discharge. So I need this one, and it needs to be high enough so when this one turns on, it doesn't the power doesn't go to the ground through here, and it goes here and charges capacitor. You can test it if you want. If you remove this one, and when this one turns off, it will not turn off the transistor. Okay, so this is the circuit. You basically just need these two resistors. This one is the high one, the 100K, and this one is the 1K. The pins are 1, 2, 3 in like this. First one is the gate, then the drain, and then the source. These two wires, the brown one and the blue one, they're connected here and here. They bring the high voltage. In my case, it's 24 volts. So this is the 24 volts, and this is the ground. All this is ground, and it's also continuous here. I was lazy here, and I just put a wire on the other side, and everything here is ground. Okay, so from these are the points already connected to the microcontroller. It's this one, the intersection of these resistors. So it's here, the one, the gate resistor. The second one is the high voltage, like I said, and the third one is connected on every one of them to the ground. Okay, so this is the transistor sign. Let's go with the thermistor now. Here is the bed thermistor, and this is the hot end thermistor. This is a very simple circuit. You use a 4.7 kilo resistor in series with the thermistor. So it's basically a voltage divider here between this and this. When this one goes lower and higher, it changes the voltage that you measure with the microcontroller here, and you using a conversion table you can get the temperature. This I'm not using this. I didn't put it in my circuitry here, but it's better to use it because it stabilizes the voltage here. Okay, so let me explain here a bit what I did. Here is the 3.3 volts and the ground coming from the micro, because there's this optocouple that separates the 24 volts from here from the 3.3 volts from here. So we have, this is the ground, this is the plus 3.3 volts that's connected between this resistor, and here it's the thermocouple pins here. This one, let me see, goes to the pin here. Okay, and the high voltage side, this one, this is the high voltage here, and it also goes here, so it connects with this resistor here. Also, it's basically a bit inverted. The 3.3 volts it's here, it goes to this resistor 4.71K here. It connects on these 2 points with the thermocouple, and the second one from here it goes through this black wire to ground, and the same to this one. Okay, and the third one, it's the inductive sensor. I've explained it in a video before, but I'll go briefly because it's on this board, so I thought I'll include it as well. Basically, this is the black box, the sensor. I draw it so you can understand a bit what happens inside. These are the 3 wires you get. The brown one is the plus 24 volts or 12 volts, whatever you use. S is the signal, the second one, It's oh sorry, it's the black one, the signal, and the second one, oh my, it's yellow here, brown, black, and blue. Okay, anyway, the blue one is the plus. Also mine it's a bit different. Anyway, this is the blue one is the plus, this one is the signal, and this one is the ground. Okay, so how this one works, you have this octocouple that is basically a LED here and a light receiver here. 24 volts come here, you have 1K, so you limit the current through this LED so it doesn't burn, and this one will turn on only when this transistor is being turned on when you bring metallic object here. So once this one goes close to the bed, it turns this one, the 24 volts will flow through this one to the ground. Once this one is turned, this one it's connected here. So basically the micro it's reading through this pull-up resistor 3.3 volts here, because normally this one is closed. So when this one becomes connected, the microcontroller gets connected to ground, so it will read 0. So this is basically how you provide 24 volts to the probe and read a signal of only 3.3 volts without burning your microcontroller. Okay, so this is the second board. Basically with the first board, the stepper, and this one, you have everything you need to run a 3D printer. Let me go a bit on the big images in case if you want to see it better. The thermistor, this is the transistor for the fans and heat bed or heaters, and this one is for the inductive sensor. Okay, this is the board, this is the back. Okay, so that's it. Next video I'll make on how to connect all these boards to the ESP32. Hope you enjoyed. Like and subscribe.